Hello everyone, welcome to my channel Coding Together. My name is Vikas Ojha. Today we will see another Leetcode problem, non-overlapping intervals. That's the question number 435. It's a medium type question. So we are given an array of intervals where each interval states starting and ending point. Return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. So let's see an example to better understand the question. So we are given with these intervals like 1, 2, 2, 3, 3, 4, 1, 3. So if we remove 1, 3, then rest of the other intervals will be non-overlapping. Similarly, with this example 1, 2, 1, 2 and 1, 2, if we remove 2, 1, 2 intervals, then the rest 1 interval, that is 1, 2, will be non-overlapping. So the minimum intervals that we need to remove here is 2. Now let's see how we can approach this problem. So we can use this in two ways. First is the brute force, where we can do using pick and non-pick way, pick and non-pick, where either we will pick the interval and non-pick the interval again. So there are two ways for one interval, and again there are two ways for the other interval, pick and non-pick, and two ways for third and fourth. So if we go by this brute force approach, we will reach a time complexity of 2 to power n, that is exponential. As we have seen for the pick and non-pick, we will have 2 to power n paths or the ways. So suppose we pick the first interval, we don't pick the second interval, don't pick, that's one way. Pick, non-pick, another way. So there can be 2 to power n permutations, combinations for these intervals to be placed, so that we reach to find out the overlapping and the non-overlapping values. So is there any better approach apart from the brute force? Yes, we can use greedy approach. So to apply the greedy approach, with the greedy approach we will also use the sorting, because sorting overwhelms greedy approach, as we know. So just a pointer here, that instead of finding the minimum overlapping intervals, we will find the non-overlapping intervals, that would be maximum non-overlapping intervals we will find. We will subtract the maximum non-overlapping intervals from the total intervals, that will give us the minimum overlapping intervals. That is the way we will achieve this problem. Now let's sort this array in the increasing n time. Why increasing n time? Because we want the intervals to end as soon as possible, so that we find the maximum non-overlapping intervals. If suppose we don't sort the intervals in the increasing n time, it can be the case that the first interval might keep on going till the end, and it might be overlapping with others. So we will not find the maximum non-overlapping intervals. So here the aim is to find maximum non-overlapping intervals, so that we achieve with the minimum overlapping intervals. So as we have sorted the arrays in the increasing n time, so this is the line graph 1, 2, 1, 2, 2, 3, 1, 3, 3, 4 that I have drawn. Let's start with our count as 1, because we know this is at least one interval that will be non-overlapping. Now we'll check the next interval, that is 2, 3, because its starting index is greater than equal to the end index of the previous interval. So that is non-overlapping. This is non-overlapping. So we have taken our start and end as this. So we will now keep our start as it is, and we will change our end to this point now, because this is greater than equal to 3. So now our ending point is this one. Now we will check for the other interval, that is 1 to 3. So as we can see that the starting point of the next interval is not greater than equal to the ending point of the previous interval, that we have the new end that we had done in the previous step. So it's an overlapping, it's not non-overlapping. So we will not take it, we will not take this, because it's not non-overlapping. Now we will check the last interval, that is 3 4. We will see that the starting point for this interval is 3, which is greater than equal to the last end, that was 3. So we will take it as a non-overlapping. So every time, so we started with 1, here we found 1 non-overlapping, we increment our count to 2. Here we found 1 again non-overlapping, we again increment our count to 3, and this is these are the maximum non-overlapping intervals. This one, and this one. So we will, as we had stated in the start, that to find the minimum overlapping intervals, we will take total interval minus maximum non-overlapping interval. So the length of these intervals is 4. We have the maximum overlapping interval as 3. So 4 minus 3 will be 1. So this is the minimum overlapping interval that we have to remove. So if we remove this interval, all the other 3 intervals are non-overlapping. So this is the minimum value we can remove. So let's see the coding part. We will first sort the arrays with the increasing ending time. We will initialize the count as 1. We will iterate over the intervals starting from the index 1, and we will take the end as the ending point of the first interval. We will compare if the starting point of the next interval is greater than equal to end. So if it is, then we will increment our count pointer, that will for non-overlapping intervals. For this count is maintained for non-overlappings, and we will update our end to the end point of the next interval, that is in this loop. After the loop is completed, we will have a count of maximum non-overlapping intervals. We will subtract from the interval's length, and we will get a count. So let's run this program. So as you can see, the sample test cases are passing. I have already submitted this code. So it's passing. So hope you like this video. Keep sharing and subscribe to my channel, so that I'll get motivation to present more such videos. Thank you.